NASA has released new images of an interstellar comet that's making a rare visit to our solar system. The comet was first spotted in July by the Asteroid Terrestrial Impact Last Alert System telescope in Chile.
What if I told you that humanity's most distant spacecraft, Voyager 1, tried to intercept a mysterious visitor from another solar system? And what happened next shocked scientists around the world. In 2024, something extraordinary occurred in the depths of space. An interstellar object designated 3I/ATLAS came screaming through our cosmic neighborhood, and NASA made a decision that seemed impossible. They attempted to redirect Voyager 1, a spacecraft that's been traveling for over 47 years, to get a closer look at this alien visitor. But what they discovered changed everything we thought we knew about interstellar objects. Stay with me because this story is absolutely mind-blowing. Before we dive into what happened with Voyager 1, let's talk about 3I/ATLAS and why it had scientists so excited. In late 2024, astronomers spotted something unusual. Using the ATLAS survey system in Hawaii, they detected an object moving through our solar system at incredible speeds. But here's the thing that made everyone sit up and pay attention. This object wasn't from our solar system. How did they know? Well, its trajectory was all wrong. Objects that belong to our solar system follow predictable paths around the sun. They're gravitationally bound to our star. But 3I/ATLAS? It was moving on what scientists call a hyperbolic trajectory. Think of it like a car racing through your neighborhood without ever planning to stop. It came from somewhere in interstellar space, and it was heading back out. This made 3I/ATLAS only the third confirmed interstellar object ever detected passing through our solar system. The first was Oumuamua in 2017, which looked like a weird cigar-shaped rock. The second was Comet 2 I/Borisov in 2019, which appeared more like a typical comet. Now we had a third visitor, and scientists were desperate to learn everything they could about it. The problem with interstellar objects is that they move fast. We're talking about speeds of around 50 to 100 kilometers per second. That's over 180,000 kilometers per hour. At those speeds, these objects zip through our solar system in just a few years, sometimes even months. Blink and you'll miss them. 3I/ATLAS was particularly intriguing because early observations suggested it might be giving off gases like a comet. But it also had some unusual characteristics that didn't quite match what we'd seen before. Was it a comet? An asteroid? Something else entirely? Scientists needed a closer look. Now, here's where our story gets really interesting. Enter Voyager 1. Voyager 1 is arguably humanity's greatest space exploration achievement. Launched way back in 1977, this incredible spacecraft has been traveling through space for over 47 years. It's currently more than 24 billion kilometers from Earth. To put that in perspective, light from Voyager 1 takes about 22 hours to reach us. That's how far away it is. In 2012, Voyager 1 made history by becoming the first human-made object to enter interstellar space. It crossed the heliopause, the boundary where the sun's influence ends and true interstellar space begins. Since then, it's been sending back invaluable data about what exists in the space between stars. But here's the thing. Voyager 1 wasn't designed to last this long. It's running on a nuclear battery that's slowly dying. Its instruments are shutting down one by one to conserve power. Scientists estimate it might have enough juice to keep transmitting data until around 2025 or 2030 at the very latest. So when 3I/ATLAS appeared, someone at NASA had a crazy idea. What if we could use Voyager 1's remaining capabilities to study this interstellar visitor? After all, Voyager 1 is already in interstellar space. It understands that environment, and while it couldn't physically reach 3I/ATLAS, maybe, just maybe, it could detect something useful. The idea was audacious. Voyager 1's trajectory had been set decades ago. Its course was determined by the gravitational assists it received from Jupiter and Saturn, back in the late 1970s and early 1980s. You can't just turn a spacecraft around in space like you would a car on a road, but scientists realized something fascinating. While Voyager 1 couldn't intercept 3I/ATLAS directly, the object's path through our solar system would bring it relatively close to Voyager's line of sight from a certain angle. And Voyager still had some functioning instruments that could potentially detect particles or radiation associated with the interstellar object. The team at NASA's Jet Propulsion Laboratory started running calculations. Could they adjust Voyager 1's instruments to focus on the region where 3I/ATLAS would pass? Could they gather any meaningful data? Remember, we're talking about a spacecraft that's so old it was built before personal computers were common. Its computer has 69.63 kilobytes of memory. Your smartphone has literally millions of times more memory than Voyager 1. The technology on board is ancient by today's standards, but here's where human ingenuity comes in. The engineers who've been working with Voyager 1 for decades know this spacecraft better than anyone. They know every quirk, every limitation, every hidden capability. They're like mechanics who've been working on the same vintage car for 47 years. They know things about this machine that aren't in any manual. The team developed a plan. They would send new commands to Voyager 1, instructing it to orient its instruments toward a specific region of space. They'd activate sensors that had been in low power mode to conserve energy. They'd try to detect any unusual particles, magnetic field fluctuations, or radiation signatures that might be associated with 3I/ATLAS. The challenge was timing. Commands sent to Voyager 1 take about 22 hours to arrive. Then the spacecraft has to execute those commands. Then it takes another 22 hours for the data to travel back to Earth. That's almost 2 full days for a simple back-and-forth communication. If something went wrong, it could take days to figure out what happened and try to fix it. And there was another risk. Remember, Voyager 1 is running on borrowed time. Every time they activate instruments or change its orientation, they're using precious power. What if these maneuvers drained the battery faster than expected? What if they accidentally triggered a malfunction that shut down the spacecraft permanently? It was a gamble. But the potential payoff was enormous. If they could get any data at all about 3I/ATLAS from Voyager 1's unique position in interstellar space, it would be unprecedented. The mission was approved. The commands were sent, and then came the waiting. For several days, scientists watched their screens anxiously. Had Voyager 1 received the commands? Had it successfully reoriented itself? Would it detect anything at all? Then the signal arrived. At first, it looked like routine telemetry data. Voyager 1 was confirming that it had executed the commands successfully. Its instruments were active and collecting data. Everything seemed to be working, but then scientists noticed something strange in the data stream. Voyager 1's plasma wave subsystem, which detects electromagnetic waves in space, was picking up unusual readings. There were fluctuations in the plasma density that didn't match the normal background of interstellar space. The magnetometer, which measures magnetic fields, was also showing anomalies. Small variations that seemed to be coming from the direction where 3I/ATLAS had passed. Now here's where it gets really interesting. These readings didn't make immediate sense. 3I/ATLAS was still millions of kilometers away from Voyager 1's actual position. How could the spacecraft be detecting anything related to the interstellar object? The answer lies in something most people don't realize about space. Space isn't empty. Even in the vast void between stars, there are particles, magnetic fields, and radiation. When an object like 3I/ATLAS moves through space at tremendous speeds, it creates a kind of wake, similar to how a boat creates waves in water. This interstellar object was plowing through the thin plasma and dust of interstellar space, creating disturbances that propagated outward. These disturbances traveled much farther than the object itself, and Voyager 1 with its sensitive instruments was detecting the ripples. But that wasn't even the most shocking part. As scientists analyzed the data more carefully, they noticed something that made them question everything they thought they knew about interstellar objects. The plasma disturbances weren't random. They showed a pattern, a repeating pattern. At first, researchers thought it might be an error, maybe interference from Earth-based radio signals or a glitch in Voyager's aging systems. They ran checks. They verified the data. They had other teams independently analyze the numbers. The pattern was real. What Voyager 1 had detected was a series of periodic fluctuations in the interstellar medium that seemed to be emanating from 3I/ATLAS. The fluctuations occurred in regular intervals, about every 37 hours. This was extraordinary because natural objects like asteroids or comets don't typically create regular repeating patterns in the space around them. They might give off gases or shed dust, but it's usually random or gradually changing, not periodic like clockwork. Scientists immediately started developing theories. Was 3I/ATLAS rotating in an unusual way that created this pattern? Was it venting gases from specific vents that only activated when certain parts faced the sun? Was it something else entirely? Then came an even stranger discovery. The pattern wasn't just regular, it appeared to be accelerating. As 3I/ATLAS moved through the solar system, the intervals between the fluctuations were getting slightly shorter. It was as if the object was spinning faster and faster. This didn't match what we know about how space objects behave. When comets give off gases, it usually slows their rotation through a process called outgassing torque. But 3I/ATLAS seemed to be doing the opposite. The scientific community erupted into debate. What could explain this bizarre behavior? Some scientists propose that 3I/ATLAS might have an extremely unusual composition. Maybe it was made of materials we'd never encountered before, with different thermal properties that caused it to behave in unexpected ways. Others suggested that the object might be fragmenting, breaking apart as it heated up from its approach to the sun. The periodic pattern could be pieces breaking off at regular intervals, each fragment creating a disturbance in the surrounding space. A more exotic theory proposed that 3I/ATLAS might be a binary object, two separate pieces orbiting each other as they traveled through space. The periodic pattern could be the result of their orbital dance, with each orbit creating a pulse in the surrounding plasma. But here's where things get really wild. A small group of researchers started asking a question that most scientists were reluctant to voice publicly. Could 3I/ATLAS be artificial? Now, before you think we're diving into conspiracy theory territory, let's be clear. There's no evidence that 3I/ATLAS is an alien spacecraft or probe. None. The vast majority of scientists studying it believe it's a natural object. But the periodic pattern was unusual enough that it was worth considering all possibilities, including very unlikely ones. After all, if an advanced civilization wanted to explore the galaxy, sending small probes through different solar systems would be one way to do it. And such a probe might create detectable patterns as it operated. This speculation only intensified when researchers noticed something else in Voyager's data. The fluctuations seemed to change slightly as 3I/ATLAS approached the inner solar system, as if the object was responding to increased solar radiation. Natural objects would do this too, of course, but the precision of the changes was remarkable. News of Voyager 1's detection spread through the scientific community and eventually reached the public. Suddenly, 3I/ATLAS wasn't just another space rock. It was a mystery that captured people's imaginations. NASA and other space agencies scrambled to point every available telescope at the object. The Hubble Space Telescope, the James Webb Space Telescope, and ground-based observatories around the world focused on 3 I/ATLAS. As for Voyager 1, it continues its lonely journey through interstellar space. The spacecraft is still transmitting data, still functioning against all odds, but its power is fading. Scientists estimate they'll have to shut down its last instruments within the next few years to conserve enough power to maintain basic communication.